Alright, so let's begin. Average velocity from a velocity time graph. Common mistake that people make. So be careful here. Whenever the average velocity is to be calculated under any circumstance, it must be done using the formula v bar equals d over t, where the displacement is calculated from the vt graph using the area under the curve or area under the graph technique. So in other words, you have to find the displacement first, and then you divide by time. Find displacement first. Okay? Here's the common mistake that people always make. I'm going to show you the mistake. Don't make it. Even having said that, there's still going to be 5 or 6 of you that are going to do it because you're not listening close enough right now. Let's cut it off at 5 seconds. What's the velocity at the start of the interval? 0. What's the velocity at the end of the interval? 4. Brandon, are you watching? So what's the average between 0 and 4? 2. But that is not how you do it. How long is it 0? Just an instant. How long is it 4? 3 whole seconds. Shouldn't that 3 whole seconds of 4 meters per second count more than an instant of 0? It would be like me giving you 100 tests, right? You got 100 on 99 of them, and 0 on the other, and I gave you a mark of 50. Would that be fair? No, not at all. You'd stomp up and down, your mom would call me, and I'd get into trouble. It's the wrong way to do it. You have to give more weight to the one that is there longer. So it's exactly what you have to do here. So you do not, I repeat, do not, when you're finding average velocity, do not take the start and the final and add them together and divide by 2. What do? You find the displacement first, and then divide by the time. Okay, so let's do that. Here's a good review for those of you that were missing yesterday. The average velocity for the time intervals A and B would be calculated in the following way. So we find the displacement. Let me just erase this mess. Okay, we break it into triangles and rectangles. So I'm going to find that area there. The base is from 0 to 2. The height is from 0 to 4. So base times height divided by 2. So we've got 2 times 4 is 8. Divided by 2 is, I heard Will say it, 4. Right? The area is 4. The area of part B, this rectangle here. How far is the base? From 2 to 5, that's a base of 3. All right, so the base is from 2 to 5, that's a distance of 3. And again, the height is from 0 to 4, that's a height of 4. 3 times 4 is 12, giving me a total displacement of 16. Okay, I found the area of the triangle, and I found the area of the rectangle, and I add them together to get 16. What is the total time of this interval? 0 to 5. 16 divided by 5. The average velocity is 3.2. Have I explained that clearly enough? Alex? Hannah? I'm reading faces. Claire? Now? Okay, so what are the steps? Find the displacements, that's what we did yesterday. Divide by the time. So in other words, here, the average velocity 3.2, it'd be like about there, right? And that's, if you sort of stop and think about it, that's kind of intuitive, right? Because it's at 4 seconds for quite a while, and it's between 0 and 4. So yeah, it should be greater than 2, shouldn't it? Right? Okay. So question number 1 on the clickers is determine the average velocity for the entire trip to 1 decimal place. Now yesterday, you were to calculate all these different intervals. Do you still have them on your sheet? Hopefully you have the right answers now, whether you got them right or wrong, right? I gave you the right answers. So now, we'll get the clickers out, they're right here, and determine the average velocity for the entire trip. Single question, You need to find the average velocity for the entire trip. So you need to find all of those displacements. You actually worked them out yesterday if you were here. If you weren't, then you can get them from the person beside you, or if you want to wait, if you want to do them on your own, that's a good idea, right? Because what's really important is not the answer. What's important is learn how to do it, right, Brendan? Okay, and then you're going to divide by the total time. What's the total time here? 14. 0 to 14 seconds. You have to do it right to 1 decimal point. You have to round correctly. It's the one right here. There's only been one so far. It's the same one right at the front. It's the same graph the entire time. Yeah. If you've got the number 0.4499999 and I ask you to round to 1 decimal place, is it 0.4 or is it 0.5? Hands up if it's 0.4. Hands up if it's 0.5. To the nearest 1 decimal place. Okay. It's this one. You do not, and I've heard of teachers teaching this, you do not do this. Make that a 5, which makes that a 5. You do not do that. 1 decimal place, you go to the next one, and you go from there. You do not do this, okay? If you've been taught that, you've been taught wrong. Okay? If you just think it's that way, it's not. But I'm hoping that you weren't taught that right. Okay. Let's move on. We're going to talk about instantaneous velocity now. Okay, I got 2 more to do here, and then I'm going to give you some time to work. Okay, so again, instantaneous velocity from a VT graph. What is this graph of? It's a velocity time graph. So Andrew, it's a graph of velocities. So how do we find instantaneous velocity? You just read it off the graph. It's a graph of velocities. You read velocities off a velocity time graph. You read it. For example, v_inst at the 6th second, right here, 6 seconds, you read it off the graph. The velocity is 2. It's a graph of velocities. You read it off the graph. Okay, here's your question. What's v_inst at 13 seconds? Go. This one should not take hardly any time at all. Yay, everyone got it. -1. You just read it off the graph. Oh, by the way, it's -1 meters per second because units are important. Okay, last one, then I'll give you time to work. Instantaneous acceleration. We're talking about a velocity time graph. How do we find acceleration from a velocity time graph? We are talking about the slope, because it's instantaneous acceleration. Therefore, we need to talk about instantaneous slope. Instantaneous acceleration is determined the same way off a VT graph that v_inst was determined off position time graphs. That is, find the slope of the VT graph. You may need to draw a tangent line if the graph is curved. If it's not curved, what do? Just find the regular slope, right? If it is curved, you have to draw a tangent line. Instantaneous slope, the slope at a single point. Okay, so go ahead and tell me what a_inst at 12 seconds is. Right there. What is the instantaneous acceleration at 12 seconds? We seem to be stalled a little bit here. Instantaneous acceleration on a VT graph, we find the slope So I'm asked to find instantaneous slope at 12 seconds. Is the slope here any different than the slope there? Or there? Or there? So all you do is find the slope. Rise over run. 0 minus 3. What's the run? 14 minus 11. Find the slope. These next 2 pages, I'm going to stop talking in about 5 minutes. Okay? And then you're going to get a test work. These next two pages are so important that I hand them back out to grade 12 students. Okay? Everything that I've just taught you is now summarized on these 2 pages. Would it be a good idea to have some sort of summary like this on your cheat sheet? Let me explain. Think of them side to side, but also like up to down. See how there's like 1 column here? Like 2 columns on each page? Okay, so this page goes like up on top. Okay, and you'll see that the left page is all about what kind of graphs? Position time graphs. Seriously, you guys, pay attention for 3 minutes. Listen. Great. Up here, eyes up there, not anywhere else. This is the learning part. Okay, if you have a position time graph and you are asked to find displacement, how do you do it? You read the final and the initial read off the graph, and then you subtract. And what I mean by that is, and you can draw it in the corner here, right? You take those 2 spots, that's XF and that's XI, and you subtract them. You read you read the positions off the graph and you subtract them. Okay? So you should be writing that little graph down thing there. Right there. It's a good visual. Right? Here's your position time graph. You read the initial position, you read the final position, and you subtract them. That's what you do to find displacement. In the next day and a half, when I'm getting you guys to work on these, the first thing when you ask for help, the first thing I'm going to do is I'm going to turn you to these 2 pages and remind you that you have all the answers right in front of you. Okay? My job is to teach you how to use this, not to give you the answer. The answer's not important. Being able to do it's what's important. Okay. If you are looking at a position time graph and you're asked to find average velocity, Kia, average velocity on a position time graph, how do you do it? Oh, Kia. I had high hopes.
Grade 11 or grade 12?
Grade 11. Is it the slope? Is it the slope or the area? Average velocity on a position time graph. Is it slope or area? Oh, I made a multiple choice for you. I even wrote the answer on the board.
Okay, when you say slope, it's slope.
Thank you. Okay? No, it's not always slope. Is the answer here slope? No. It's find the 2 and subtract, right? Average velocity on a position time graph. Now, there's 2 possibilities. It could be a straight line graph, and if it is straight, then you find the slope. Watch here, you guys. Like, just seriously, I need like 3 or 4 minutes. But what if it's a curved line graph? What do you do? Average velocity. What do you do if it's curved? You draw a line between, it says the points of interest. You find the slope of this line. Average velocity. You find the average slope. Oh yeah, you don't need to draw a line. But for the visual, I'm drawing a line. Okay? So if it's a straight line, you find the slope. If it's a curved line, you draw the line between the points that you want and find the slope. Average velocity implies over a interval, right? Is physics as hard as you thought it would be? Harder? About what you expected? Okay. What if you have to find instantaneous velocity? Instantaneous implies instant whatever. It's velocity, so we're talking again slope, and there are two possibilities. It could be a straight line graph, and if it's a straight line graph, then you find the slope. Do you need to use the endpoints to find the slope? You can use any 2 points, right? People tend to use the endpoints. What if it's a curved line graph? Tangent line. Tangent line. Brandon, can you take that? Okay. Now, most times when you're on a page, you finish that page, right? But we're going on to the next page, still the first column. You see how it works? The whole column is position time graph. See that at the top? Okay. Can you find average acceleration from a position time graph? No, you can't. It's like, the velocity is the slope. There's nothing else to calculate. You can't do it. It's the second derivative. We don't have that ability yet to find derivatives. Can you find instantaneous acceleration? Oh, can't do it. It's, again, the second derivative. Okay. Now let's talk about column 2. Velocity time graphs. That's what I've been talking about for a day and a half. Almost done, Brady. Almost done. I can see you're wandering, you're fading here, man. Stay with me 3 more minutes. If you are given a velocity time graph and you're asked to find the displacement, what do? You find the area. You find the area between the VT graph and the time axis, time coordinate, and you divide the area into rectangles and triangles and so on and so on, and above is positive and below is negative. But basic main thing is find the area. There's your visual. Velocity time graph, you're looking for displacement, find the area. If you are asked to find average velocity, what do? V bar equals d over t, where d is calculated as shown in number 1. So in other words, you have to find the area and divide by the time. Do you see how I'm giving you all the steps, all the pieces of the puzzle, everything you need to know, all in one handy 2-sheet summary? If you have a velocity time graph and I ask you to find instantaneous velocity, well, that's the easiest one of the bunch because what do? You read it off the graph because it's a velocity time graph. And flip the page. If you have a velocity time graph, Andrew, like 2 more minutes, man. Just hang in there. I know. Well, because I keep having to stop all the time. If you have a velocity time graph and you're asked to find average acceleration and it's straight, what do? Find the slope. If you have a velocity time graph and you're asked to find average acceleration and it's curved, you draw the line between the 2 points of the integral and find the slope. If it's a curved line graph, same idea as this one. Do you see how they're related? Kind of offset kind of thing, right? It'll make more sense to you when you take calculus. Not plan taking calculus? Oh, well, they have calculus at universities. They kind of... Okay, last one. Velocity time graph. If you're asked to find instantaneous acceleration and it's a straight line, you find the slope. And if you have a velocity time graph and you're asked to find instantaneous acceleration and it's a curved line graph, tangents. And that, my friends, is just about everything you need to know about position, time, and velocity time graphs. Now, I am not naive enough to think that you all get it 100% right now. I've looked around the room, I've read faces, I've used my experience. I can see that we need to talk. Immediately, I have provided for you 1, 2, 3, 4, 5. 5 pages of practice, and I have been a jerk and I have not given you the answers. Wow, okay. I have solutions for the first 4. I have the answers, but apparently I didn't give them to you. So you guys start. I'm going to go cook up the answers. The solutions, I will post the Schoology as well, the solutions. They are available. I don't know if I've ever told you this. I have a binder here. It contains Physics 30S solutions. It's conveniently labeled with the words Physics 30S solutions. It contains solutions. Okay? For almost every worksheet. So actually we are moving through a little bit here. They're right here. Velocity time graphs. So I'm going to leave that right here. If you need to come and look at it, you can. I will post those solutions when I scan them. I will post them to Schoology as well, so you can get them on your phone, and I'll get you some answers right away. I'm not a fool. I don't think you're going to be able to do all 5 for tomorrow. That would be silly. But at the very least, you should do the first one for tomorrow, and then we'll reevaluate how much more time you need. Okay? So do the very first one for tomorrow. The very first draft. If you get farther than that, that's great. But you got to have the first one done. I think that's fair in 20 minutes. Begin. Yeah, go.